One of the most important changes in the firepower of the modern mobile army since the Korean War has been in the development of missiles. While delivering the punch of heavy artillery, they have the maneuverability of light weapons. One of the earliest members of the Army's family of surface-to-surface missiles is the Honest John, which has been operational for over 5 years. It can carry a high explosive or nuclear warhead with the punch of hundreds of artillery shells in a single shot. Honest John is a long-range artillery rocket using a solid propellant. Like artillery, it can be used to provide close fire support in ground combat operations. Transported on its own self-propelled launcher, it has a high degree of off-road mobility. A free flight rocket, as distinguished from a guided missile, it requires no electronic guidance. It is therefore relatively simple to set up and can be aimed like an artillery piece. This powerful tactical weapon has a range equivalent to medium and heavy artillery. It was only natural that Army research and development should pay particular attention to a weapon with this potential. The Closer missile is a smaller, improved model. It is 1,000 pounds lighter than the older version behind it. The performance of the new Honest John is better than the old. It is more accurate, requires fewer accessories, and no additional men to operate. During research and development test firings, such missiles are painted red for easier tracking. When they join the Army in the field, they take on a coat of olive drab. The new version is simpler and more rugged than the earlier model. The self-propelled launcher also has been considerably lightened to increase its air transportability. An extremely lightweight launcher, now in the hands of troops, can be parachute dropped. This latest Honest John is an example of the continuing task of Army research and development, which is to improve the strategic and tactical capabilities of all weapons. Little John is being developed as a lightweight missile primarily for use by airborne troops. To increase its accuracy, it spins before firing. This free-flight surface-to-surface rocket, developed by the Army, has a solid propellant to give it the range of medium artillery. Little John has been issued to the 101st Airborne Division for training and development of combat techniques. Here, a research and development test model is prepared for test firing at the White Sands Missile Range, New Mexico. Since Little John is light in weight and simple to operate, it can be brought into action speedily by a crew of 8 men. It can be flown in standard Army aircraft or dropped by parachute. While the missile was undergoing tests of its performance at White Sands, the high mobility of the weapons system was being proved at Fort Bragg, North Carolina. Helicopters took the weapon and its crew on various airborne missions. In one airborne test, Little John and its prime mover were lifted together outside the helicopter. The 8 men of its crew were passengers inside. In another training exercise, the crew, Little John, and its lightweight launcher were flown and landed inside an H-37 helicopter. Even the jeep used to pull it was aboard. While operational tests are made under as realistic conditions as possible, Little John is considered to be in the research and development stage until authorization is given to turn it over to troops. Cross is a solid propellant, command-guided missile designed to provide the Army with a light and extremely accurate weapon. The missile can carry any one of a variety of warheads. Its range is equivalent to that of heavy artillery. One of its missions is to knock out heavily fortified targets, such as this bunker. The launcher crew is in direct contact with the forward guidance station, normally located near the front. This forward station locates targets and guides the missiles to those targets. When word is received from the Fire Direction Center that fire is desired against a certain target, the missile is raised to firing position. Then, after the missile is launched, it climbs to a pre-selected altitude and flies toward the target. The forward guidance station then guides it to the target. This is the bunker after the hit. Lacrosse equipment was issued to troops in 1959. A new chassis, known as the T-236, has many uses. Due to a unique suspension lockout system, it can be used to mount any one of three weapons: the 8-inch howitzer, the 155mm gun, or the 175mm gun. This is the T-236, self-propelled 8-inch howitzer. Weighing 28 tons, it has good cross-country roadability. T-236 can climb an obstacle 40 inches high. And it is able to cross streams with a depth of 4 feet of water. Highways, it moves along at a brisk 30 miles an hour. The new artillery weapon has a crew of 5 men. It can be emplaced, ready to fire, in 10 minutes. Successful firing tests have been conducted with all 3 weapons mounted on the same model carriage. Due to its novel lockout suspension system, the T-236 chassis, mounting the 8-inch howitzer, has good stability during firing at all angles of elevation and traverse. The same lockout suspension system makes the chassis an ideal platform for an armored wrecker and recovery vehicle known as the T-120. The cab of half-inch armor plate encloses the entire wrecker for all-around protection of crew and equipment. With excellent cross-country mobility, it can tow up to 30 tons. In spite of relatively light weight, the T-120 has great stability as a wrecker. Here again, the hydraulic suspension system permits control of the rigidity of the suspension, and outriggers are not required. In the driver's compartment, there is a single valve to control the suspension. The T-120 can lift and swing a total of 10 tons. From the boom tip, it can lift 15 tons, and almost double that tonnage from mid-boom. Stability as well as maneuverability are maintained while the vehicle is in motion. A new development and supply of fuel for the highly mechanized modern Army is the rolling fluid transporter. By using its own wheels as containers, It cuts down on both weight and the power required for hauling. The design is simple. It consists of an axle and two large tires, each with a capacity of 500 gallons. The rolling units are easily brought alongside any bulk fuel source for filling. Couplings in the inner rim of the tires can be connected rapidly for filling and air venting. The filled containers can be towed away by any military vehicle equipped with a pintle hook. When these tires are used to transport fuel, they can be emptied either by means of an air compressor or a hand pump. For transportation of large volumes of fluid, as many as 10 tires in 5 rolling units can be hauled in tandem over a level, hard surface by a 2.5-ton truck. Many types of wheeled vehicles and even armored personnel carriers can tow the units over terrain too rough for conventional gasoline tank trucks. Rolling fluid transporters have also been dropped from the air. Towed by a duck or other amphibious vehicle, the rolling fluid transporters can also put to sea. This will prove useful for ship-to-shore supply or for rapid movement over rivers without bridges. Besides reducing the number of prime movers and drivers needed, the rolling fluid transporters promise to give greater flexibility to the system for supplying fuel to the modern Army. There is a new answer to that old military problem, how to cross small rivers and streams. It is an armored vehicle which can carry and launch its own bridge. Since ancient times, military commanders have sought ways to move armies across streams without concentrating their forces in vulnerable positions at fords or bridges. Fast-moving attacks had to be halted, while bridges were thrown across relatively narrow streams. Army Research and Development can now report operational success of an unusual vehicle. It is a bridge and hydraulic launcher mounted on a standard tank chassis. Made of aluminum alloy, the bridge is folded onto the launcher for transport. It can be extended within 3 minutes to a span of 60 feet. The bridge has 2 treadways, each large enough to accommodate a Jeep. Medium tanks use both treadways. Capacity of the bridge is 50 tons. The vehicle can be operated by only 2 men who are protected by armor while launching the bridge. Once the armored column has crossed, the launching vehicle itself crosses over. It can then retrieve the bridge within 10 minutes and move on, ready for another crossing, thus providing maximum mobility to its armored unit wherever it may go. The new twin-engine all-purpose Caribou is typical of the so-called STOL, short takeoff and landing, fixed-wing aircraft. Such planes are being developed by the Army to operate more closely and effectively with troops in the field than ever before. Capable of taking off from much shorter runways and more rugged terrain than most standard aircraft, Caribou can carry a payload of 3 tons. It weighs 13 tons loaded, thus making it the heaviest aircraft in the Army. Procurement of this useful plane was made possible by the Secretary of Defense, who permitted a deviation from the 5,000-pound weight limitation normally imposed on Army aircraft. Caribou can bring supplies into small, unimproved landing strips, landing at 60 miles per hour. In the Army, Caribou will be used mainly as a troop transport and cargo carrier within the field Army area. The rear loading ramp with its wide opening door permits rapid loading or unloading of troops, supplies, and equipment, such as jeeps. Caribou accommodates 32 fully equipped combat infantrymen. On the return trip from a battle area, it can hold 14 litters and 10 seats for evacuating wounded. 2 men, the pilot and co-pilot, comprise the crew of this improved utility aircraft. Tests to meet Army requirements have proved the worth of Caribou's powerful engines, which enable it to take off fully loaded in less than 1,000 feet over a barrier 50 feet high. The first operational Caribous have been delivered to the Army for rugged service testing in the field. With its large carrying capacity and short takeoff and landing characteristics, Caribou will make a special contribution to the Army's tactical mobility. Because speed of attack and quick dispersal will be highly important in any future war, the Army constantly seeks ever greater air mobility. The Iroquois, a turbo-powered helicopter, is typical of the modern look of today's Army aviation. Iroquois is now being delivered to operational units of the Army. Designed specifically for Army needs, it is wide enough to take litters for the air evacuation of wounded and rugged enough to live with the Army in the field. In addition to the pilot and co-pilot, the Iroquois is capable of carrying a payload of either 800 pounds or 4 combat-equipped soldiers. It will run on jet fuel, kerosene, or automobile gasoline. Since its parts can be quickly replaced, Iroquois is particularly easy to maintain in the field. It can make instrument flights by day or night, providing a quick means of moving troops and equipment in and out of areas inaccessible by surface routes. Helicopters, such as the Iroquois, are bringing true air mobility closer to reality. The Doak research aircraft is only one of a number of promising vertical lift concepts now being studied by Army Research and Development. Ducted fans mounted on the wingtips provide the propulsion. By rotating these ducts, a successful conversion from vertical to forward flight is effected. Such tests may lead to design of an efficient aircraft fully capable of operating without runways. Commanders in the field will then be able to visit almost any part of a battlefield at will. At the same time, the ability to convert to forward flight will give such an aircraft greater speed and range than are now possible with other vertical lift systems, such as the helicopter. The Doak has proved its ability to hover in flight. Ducted fans have been found to be more efficient than other lifting propellers. Another advantage of a convertible propulsion system is that such a design can operate with a much heavier payload from longer landing strips if vertical takeoff is not required. Its rotating ducted fans also can be used as brakes for short landings. Tests are continuing as part of the overall search for new ways of achieving true air mobility, essential to the modern Army. No matter how many times the modern soldier gets a ride, his most important means of transportation will always be his own 2 feet. The Army has experimented with a new way to mold the soles of combat boots in one automatic operation, eliminating 38 steps used in making the older style boots. With special machines, one man can produce more than 100 pairs of such boots in an 8-hour day. The molded construction provides a waterproof seam at the juncture of the leather upper and the sole, which has been found to be completely waterproof. As proved by the equivalent of thousands of miles of wear, the new Army boots retain their original shape and appearance 30% longer than the old combat boots. The degree of water resistance is thoroughly tested. Tests are made to determine how much wear the boots can take under combat conditions. Field repairs have been an important problem with the older boot on the right, with its nails, stitches, soles, and heels. Simpler construction of the new boot will eliminate the need for trained shoemakers in the field. One contribution of Army research and development may someday save the lives of firefighters everywhere. It is an aluminized suit which has been severely tested by soldier firefighters from Fort Lewis, Washington. This low-cost aluminized suit consists of a parka with hood and a pair of leg sleeves and mittens. Considered expendable, the suit utilizes the principle that aluminum combined with insulating craft paper is a good reflector of heat. Volunteers in a special test of the new suits went through an exercise in which a supposed victim of smoke and flame was rescued. The victim was covered, using the suit like a blanket, and further shielded by the rescuer himself. Flames from the raging forest fire passed over both, leaving them unharmed. Dressed in one of the suits, the victim then was led back to safety. The aluminized suit is undergoing further tests by the United States Forest Service, with which the Army frequently works during the fighting of forest fires. The Army's Q-5 is a target missile used to test America's defenses against air attack. Guided from a missile control station, Q-5 can simulate a great variety of supersonic missiles. In this high-altitude evaluation of the Nike Hercules, the Q-5 target was carried aloft by a B-50 bomber to give it a boost in speed and altitude. Nike Hercules, the Army's highly accurate solid propellant air defense missile, which is replacing the Nike Ajax, is raised to launching position. At the White Sands Missile Range in New Mexico, it rests on its launching pad in readiness for this test interception of the Q-5. As the B-50 reaches maximum altitude, the target is released. The Q-5 first falls clear, then after the boosters fire, its powerful ramjet engine will shoot it ahead at more than twice the speed of sound. Nike Hercules, in more than 500 test and training firings, has demonstrated an amazing ability to seek out and destroy various targets, from about 1,000 up to more than 150,000 feet in altitude. This intercept, altitude above 60,000 feet, target speed in excess of 1,500 miles per hour. The Hawk is one of the Army's newest air defense weapons. Designed as a mobile air defense unit, it will be used primarily to destroy fast-flying attack Detection devices enable it to home on its target. Hawk seeks out and destroys the QF-80 at an altitude of 500 feet and a range of 6 miles. This direct hit on a jet fighter plane is a dramatic example of the recent advances in Army air defense. Army's Research and Development Program is a continuing effort to help ensure the survival of this nation. Army industry teamwork is essential to the accomplishment of the Army Research and Development mission. To maintain superiority in our military arsenal, new ideas are essential. New weapons must be developed and perfected to meet new requirements. In these days of explosive advances in science and technology, Army research and development plays a major role in maintaining America's military supremacy. The objective of U.S. Army research and development is to develop new weapons and equipment to support the individual American soldier. As never before in history, the future of your Army depends today on its research and development program. The battle of brains and pencils and blueprints, of imagination and innovation, is being waged in laboratories and industrial plants across the nation. The Army's research and development program covers many areas. There must be greater mobility on the ground and in the air. The need for increased firepower is being met with weapons that are smaller, lighter, and more potent. For command and control, better communications are required. The modern Army needs and must have improved logistical support that is more responsive and flexible to match fluid battlefields. With each technological advance, the importance of the individual soldier increases. Thus, the Army Research and Development Program is concerned primarily with this soldier. Research and development is constantly striving to give the American soldier every advantage in any future combat. Not only must this soldier be better trained, but he must be able to exist in the severe environment of nuclear or chemical attack. To show some accomplishments thus far, as well as new concepts being tested, here is a special progress report from the files of the Office of the Chief of Research and Development, Department of the Army.